750 people attended a conference. The introductory speaker was a bit of a joker. I bet anyone here $100 that there are at least 3 people here with the same birthday. Was he taking a risk with his money? Justify your answer. Well, there's 365 days in a standard year, but in this question we're covered even for a leap year. So let's just imagine the worst case scenario. So let's imagine that the first 365 people we choose have their birthdays spread out over the year like this. Then if we just double 365, that's 730. So person 366 all the way to 730, if they're spread out, so they've all got different birthdays. Now we've got 2 people with the same birthday, and then the very next person, the 731st, must have a birthday that's the same as one of these days of the year, and so he's not taking a risk with his money. In how many ways can 7 identical blocks, each painted different colours, be arranged in a line with no restrictions? So there's 7 of them, so that's just 7 factorial. So 7 factorial is 5040. The red and yellow blocks must be on the ends, so we can have red and yellow, and then there's 5 other blocks that can go in the middle, so that's 5 factorial, but of course these can switch ends as well, so that's going to be 2 times 5 factorial, so 2 times 5 factorial is 240. How many of the counting numbers from 1 to 6,000 have neither a factor of 2, 3, nor 6? So let's look at factors of 2, 1 to 6,000. So 6,000 divided by 2 is 3,000. So there are 3,000 that have a factor of 2. 6,000 divided by 3 is 2,000. So there are 2,000 which have a factor of 3. And 6,000 divided by 6 is 1,000. So there are 1,000 with a factor of 6. But of course these ones have already been counted amongst these. If we look at that as a Venn diagram, and we have the 2's and we have 3's, then the middle here is the 6's. So we need to do 3,000, add 2,000, and then take out 1,000 so that we don't count this twice. So altogether that gives me 4,000. And we want the ones that don't have the factors, so that's just going to be 6,000, take away 4,000 is equal to 2,000. We want to prove that nk, remember this means nck, is equal to n over k times n minus 1, k minus 1. So let's have a look at the left hand side to start with. So we have nck, which is n factorial over k factorial n minus k factorial. Now let's consider the right hand side. So that's going to be n over k multiplied by n minus 1 factorial over k minus 1 factorial. N minus 1 take away k minus 1 factorial. So that's going to be n times n minus 1 factorial over k minus 1 factorial, multiplied by n minus 1, take away k plus 1 factorial. N times n minus 1 factorial is n factorial. K times k minus 1 factorial is k factorial. And if we simplify that, it's n minus k factorial. So we have the left-hand side equal to the right-hand side.